Welcome back, friends. Dan Vega here, Spring Developer Advocate at VMware. Today we're going to be talking about structuring your code in your Spring Boot applications. So you have an idea for the next project you're going to work on. You head over to start.spring.io, you fill in some data about that project, you pick your dependencies, you download that zip file, you open it up in your favorite IDE. What do you do next? That's where we're going to start by beginning to take a look at some of the best practices, maybe some things that you might want to avoid. And then we'll talk about how you might want to organize your code in your application. The nice thing here is Spring Boot doesn't have any restrictions on how you can organize your code. It gives you free reign to do whatever you want. And maybe that's a good thing, maybe that's a bad thing. But I do want to stress that there's no wrong answer here, right? Because you can put your code wherever you want, however you want, there is no wrong answer. So everything we're talking about today is really just a discussion, some things, some personal opinions of mine, things that I've learned over the years, but there is no wrong answer. Don't watch this video and walk away and feel like you have to restructure all of your applications, because you don't. This is just a discussion on how to structure your code. So we're going to talk about a few of the approaches you can take today. I'll mention some other ones. We're not going to dive deep into those yet. We will get to those. Again, this is kind of the beginning of the discussion, at least on this channel. So we have two that are very popular here, which is package by layer and package by feature. And I just want to make sure we're all on the same page before we move forward with this. So package by layer is breaking your application up into the different layers. So in a web API, I may have controllers. I may have a product controller. I may have an order controller, customer controller, etc. Outside of the controllers, I have things that represent those domain or those entities, right? Things like product, customer, order. I may have a service layer that handles all of the business logic, right? In the controller layer, well, this is kind of a dumb, I take request, return response type of thing. I may delegate to a service to do something. In the same vein, I may delegate to a repository for data access. And then I may have configuration like my web config, my security config, and so on. So I may create packages for those and put all the related code in those packages. So I would have a product controller, order controller, customer controller, all in the controller package. So that's one way. Another way is to package by feature. So in that same system, I may have a product package. Everything related to product lives in that package. So the product domain, the controller, the service, repository, configuration, etc. Those are all stored in that particular package. And then you have vertical slices for each of the features in your application. Now, for me, there are pros and cons to each. I'm going to include this repository that has a README in it that's going to go through all the stuff that we're going to talk about today. So you'll find that link in the description below. But again, I want to quickly just take a look at this so we know what we're getting into. So what we're going to cover today is no default packages. So we'll see what that means. Hey, let's put our code in the same package as the main application class. How to organize your code. Again, we're going into package by layer and package by feature. I've included two articles that I found really helpful when I was going through kind of my discovery of this. Also, there's hexagonal architecture. So I know Thomas has a really good book on this that I have back here, which I haven't read all the way through, and now I feel like I need to go back through it. But there's already second edition, so I may need to get that second edition as well. Also, my friend Ted Young has a bunch of information on this architecture type, and I'll be talking to him soon to get a little bit more in depth on that. And then there's the Spring Modulith project, which is new. It just hit 1.0 over at spring.io. This is something to check out. I'm going to be talking to Oliver about this as well. So there are all different ways that we can start to organize our code, set up our architecture. I want to talk specifically about package by layer and package by feature today. To do so, I've included some concepts that we should know about, really software design principles. The main two are cohesion and coupling, right? Cohesion represents the relationship within a module. Coupling represents the relationships between these modules. Generally, in software design, you are aiming for loose coupling, high cohesion. Not so great if you have high coupling and low cohesion. Again, this isn't the absolute rule of everything. This is just some best practices to follow. And encapsulation is another thing. Again, just the idea of information hiding also refers to the limiting of direct access to some data, thinking, access modifiers like public, right? So those are some things to understand. I also have some pros and cons or reasons why I might pick package by feature over package by layer. Again, not a right or a wrong thing, just an opinion. And we'll take a look at these as we go out and write some code. I also put this out on Twitter and on LinkedIn. I just want to say thank you to everyone who responded. I said I was working on a tutorial for structuring your code in Spring Boot. Here's package by layer, package by feature. And I got so many great responses. As you can see, just a couple days later, we have 68,000 views on this, 550 likes, 111 comments. Like, everybody was really engaged with this. I got a bunch of really good comments in favor of everything. Package by layer, package by feature, a little bit of both. Again, no wrong answer here. I will also leave a link to this Twitter thread in the description. If you're interested in seeing which side you're on, there's a lot of really great arguments for both. So go ahead and dig through this. With that, I want to head over to start.spring.io, and we're going to create a new project here. I'm going to use the latest milestone of Spring Boot 3.2. I'm going to say dev.danvega. I'm going to go with code structure. Let's just say let's say code structure demo. That's the name of our artifact. I'm running the latest and greatest Java 21. You can pick whatever you want. It won't really matter for this particular exercise. I'm just going to pick a web demo or web application. And what I'll do is I'll go ahead and generate this, download the zip, open it up in my favorite IDE, which is IntelliJ. You can open it up in whatever IDE or text editor you're most productive in. With that, let's go ahead and write some code. All right, so before we get into how to organize your code, I want to talk about a couple best practices here. The first is you don't want to use the default package. And what do I mean by that? We have our main package here, which is dev.danvega.csdemo. I can come up here into the Java folder here and create a new Java class. Let's just say this is called message handler. And we'll have this as a class. And you can see there's no package declaration here because this is in the default package. So even if I go off here and go ahead and mark this as a component. Now, if you're wondering what component is or what bean is, what the application context is, I'll go ahead and leave a link to a video I've done on component versus bean, how this all works in the application context if you want to learn more about that. But if we go ahead and mark this as @component and we go ahead and run our application here, and in IntelliJ, I'm going to use this nice little feature in here. If I come in here and say, I'm going to come in here and select this Spring window, and this gives me some insight into my application, what beans are available in the application context. And as you notice, message handler, even though I've marked it with that component, is not in the application context. Why is Spring not picking it up? Because again, it is in the default package. So if we want to move that into this package, we can say refactor, and now we see it there. So along the same lines, that's kind of best practice tip number one. Along the same lines, I may not want to create another package here called, let's just say we have model here. So in our CS demo, this is where our main application class is. And then in model, I create, let's go ahead and move that over to here. And now if I go ahead and restart my application, because this is not in the default package scope, then we would think that this would be available in the application context. If we go over here to our Spring window and look at all of the beans available, this is not available. And why is this? This is tip number 2, place all of your code in the same package as your main application class. So the main application class is in this package. Our code is actually one level up and in another package. So Spring does not see this. Now there's a way to get around this. You can say, hey, I need you to go ahead and scan for that. Where am I scanning for that? I'm going to say that, let's see, our CS demo and dev.danvega.model. So now we're saying, hey, don't just look in that main base package, look in my model package as well. And then as you can see, this updated down there, it will now find this. But again, you're going to run into some issues there. If you can avoid it, just go ahead and put all of your code in the same package as your main application class. All right, so the only thing I'm going to do here is I'm going to come in here and add a new README file. And I'm just going to copy in that text we took a look at before. We're going to be revisiting this just to kind of talk about some of the choices that we have here. All right, so I'm going to start to build out an application here. I might start with a package of model. So this is going to be representing whatever the models are, the domains in my application. I'm going to start out by building a post. I'm building a blogging application. Yes, I've used this a lot recently, and I'm sorry about that. We'll kind of move on to another domain soon, but for now, this is familiar. So we're going to build out a post. So this is going to be a record in this system. This is going to take in, yes, that looks pretty good. So thank you, Copilot, for that. This is going to have an integer ID, a user ID, a title, and a body. So that is our post. Next, I might come in here and create something like a controller. So I'm going to have a way to respond to requests and return responses. So I'm going to come in here and say this is going to be a post controller. This is going to be a REST controller with a request mapping of /API/posts. And we might have something in here like a get mapping that would return a list of posts, right? So let's say list of posts, find all. How do we get those posts? That is where our fun comes in next. So we might have a service or a repository. So again, you might have packages like service, and I know that I've had a repository and maybe some configuration. So these are all the different things that I might have, the different layers in my application. And again, that's why we kind of call this package by layer. So I might have a post repository here. The post repository we'll go ahead and mark with @repository. In another system like Spring Data, this might be an interface that extends one of Spring Data's repositories. We're just going to do something simple here. We'll say that we are going to return a list of posts, and these will just be an in-memory representation. Yes, that looks good. And now in my post controller, I would get a reference to that. So I'm going to say private final post repository, and we'll get that through constructor injection. And then we'll just say repository.find, come on, Dan. There we go, find all. So this is pretty familiar for me. This is kind of how I build a lot of my applications. And, honestly, for smaller applications, I don't think this is a big deal. I don't mind kind of going this route, but I want to take a look at some of the issues that you might come up with here. So let's talk about package by layer. Does this promote best practice? Remember, we talked about cohesion and coupling earlier. Good software design principles say loose coupling, high cohesion. In this scenario, we have low cohesion and high coupling along with low modularity because everything that revolves around a post is now split up into all of these different packages, which gets to encapsulations. Most of the classes need to be public. So our post repository was public, our post controller was public, our records public, our configuration, our service, everything has to be public. And this kind of goes against everything we would do in a normal Java application. So modularity, since each layer is limited to classes related to a particular layer, it's difficult to break down this code into separate services later on. If I wanted to go down and say, for whatever reason, posts were going to get broken into its own microservice, how would I do that? I'd have to go into every single layer and start to pick out the pieces of code that I needed to split out. As opposed to in a package by feature, I can just grab everything in one package and move it over to another service and be done with it. Maintainability. Since classes are scattered across packages, it's difficult to find the classes you're looking for. If you want to add a new feature to our package by layer application, you're going to be touching 10 different files against 10 different packages. Same thing with testability. Since all classes are public, they can be accessed by testing any package. This allows you to write less focused tests. And then, hey, does this promote domain-driven design? Not really. This type of code organization or arrangement really promotes database-driven design. And we don't want to design our applications just based on database design. All right, so this leads us to package by feature. Now we might come in here and create different packages based on the feature that we're working on. So I might have something like post, and then I might have something like comment, and so on, right? So if I go into post, I'm actually just going to paste some code in here. This is less about the code and more about the organization, but I do want to walk through some of this code because there are some significant differences. So first off, we see that, as I come into this project and I look at the post package, I see everything that is related to a post in a single package. Now, if I'm working on a feature related to post, everything is kind of right here for me to jump around and find things. Also, when we go into things like post controller, you can see that this class is no longer marked private. So the default in Java is going to be package private. That means everything within that package has access to it, and everything outside of that package does not. Now, this will mean that, hey, for maybe a service, I may have to open this up to other packages, right? And that's okay. But by default, we don't want to just automatically open everything up, because then we start to get all these different packages, talking to all these different packages, and we lose some of those best practices, right? So you can see my methods are not public either. Here I'm just saying, hey, return a list of posts. And again, I think this is the power of this, is we get to kind of use that everywhere. So here we're using package private again, and so on throughout our repository here. So based on this, let's go ahead and take a look at our README again. And now I want to go into package by feature. This promotes best practices like high cohesion, low coupling, high modularity. Encapsulation, again, it allows us to, some of our classes can change their access modifier to package private instead of just making everything public. Again, we talked about the modularity. Being able to break out this into its own service seems like it will be significantly easier. Maintainability, being able to find things, testability, and promoting domain-driven design here instead of database-driven design. So those are the two: package by layer, package by feature. I also saw a lot of comments of people saying, hey, depends on the size of the project. Sometimes I may break it down by feature and then by layer. And so I'd really like to hear from you guys, what is the advantage of doing that? For me, I think you're losing a lot of the same benefits that that moving to package by feature gives you. If you're just adding layers underneath that, you're kind of adding some side effects there, right? And not getting all the benefits of package by feature. So again, I will leave a link to this README with all of this information. Thanks to these articles for the wonderful information. Thanks to Thomas and Ted for some deep dives into hexagonal architecture. And thanks to Oliver for Spring Modulus. Again, we're going to be getting into all this a lot more. This is just kind of my initial thoughts and my opinion. Again, my opinion doesn't mean it's right, doesn't mean it's wrong. Just my opinion. I'd love to hear from you guys. We saw a lot of the feedback on Twitter. I'd like to hear from it here on YouTube as well. What approach are you using? Why do you think? Do you agree with some of the things I've said in this video? Do you disagree? If you do, that's great. Let's have a discussion about it. But I think really what I hope is that you learned something today, that maybe you got something out of this. Maybe you didn't know about a certain structure and it led you down a path to kind of learn something new today. So, hey, if you did learn something new today, friends, do me a favor, give me a thumbs up, subscribe to the channel, and as always, happy coding.